Hey, what's up? It's Take here. Welcome back to the weekly blog. So I've got some good news and the bad news today. So let's start with a good news one. So I've been working on implementing the in-app purchase for iOS, and I've finished doing it 70%. I implemented the screen for managing subscription, so users can purchase Inkdrop here. And this screen shows that there is an active plan, which is a monthly plan here. So yeah, it's good. I've also implemented the server side to handle the notifications from the App Store. So Inkdrop can maintain the subscription state of the users. Hopefully, I'll submit a new version to the App Store next week. Yes, so let's talk about bad news. I've got a brute force attack on my server of the Inkdrop. So this happened last Wednesday, and I was about to sleep, and I suddenly got an alert from the server, and that is about a high load, the server high load. And at first, I looked into the server log, and I thought it's a sign up rush, but it was not. So the number of signups looked normal, and so I looked closely into the server logs and found that there were so many invalid user credential errors. So it looks like it was an attack, and so the server is getting a lot of requests to the authentication endpoint, and the requests are so they were trying to authenticate with a random stolen credentials, like random stolen email address and the password. So it's a so-called credential stuffing. So what is a brute force attack? It's according to Akamai. Let's read this. So the in brute force attacks, three actors attempt to access user accounts by entering a large number of username and password combinations into login pages on websites or web applications. So they send a huge amount of requests to the server to gain account access, and the requests were sent from random IPs to make it hard to block. So it looked like they were using a botnet, exactly like this. So the attacker instructs a bot coordinator to send a huge amount of requests through the botnet, and so they were using a stolen passwords, just like credential stuffing. So attackers use known password acquired from data breaches to attempt to log into a variety of other sites. So this approach is successful even when users have complex passwords, because many individuals reuse the same credentials across a wide range of accounts. And that makes sense. So the server logs looked like this. So many requests were sent from random IPs to my server. Yeah, it was so hard. So yeah, I was like, well, let's calm down and take a deep breath. And so the good news was that the credentials were completely random. So it didn't mean my server was breached. So my users' information was safe. That's good news. So I started investigating, and I decided to stop running the server for a while, and treat it like this. So I asked my followers that how to mitigate it, and so it looked like DDoS, distributed denial of service. But it's not, because it should be more huge amount of requests to the server. to make my service unavailable, and so my server was running fine with a little bit high load. So yeah, it was not a DDoS. And so why did that happen? So why did that happen? A few years ago, I experienced a similar attack. That is this. So I was misunderstood that this is a DDoS, but it was not a DDoS, but spam. So so it was like this, and so they exploited my API to send a spam through my server. Because Inkdrop has a API to create an account from the website, and it sends a confirmation email to a new user. And this attacker used this API to send a spam link through confirmation emails. So I decided to, I've implemented a reCAPTCHA on the sign up and login pages of the website to prevent this type of attack. And this time, the requests were sent to another API. That is for my client apps. Inkdrop is a multi-platform app that can run on mobile and desktop platforms. And my client apps my client app use a different API to authenticate. So this API wasn't using a reCAPTCHA. So it seems that the attacker analyzed the requests that the client desktop app sends. So that's why the incident happened. In order to mitigate this attack immediately, I decided to implement a simple rate limiting technique that is called leaky bucket algorithm. So people said on Twitter that I should use a rate limiting technique, and since the attack is from various IPs, it is hard to block based on the IP. So instead of using the IP, I simply implemented a leaky bucket algorithm that is not based on the IP. So let me explain that. So this is the page about the leaky bucket algorithm for rate limiting. And the idea behind the algorithm is simple. Imagine that there is a bucket of tasks that are being filled with incoming tasks. This bucket also has holes at the bottom that tasks can drip down into the task processor. So it looks like this. So if there were too many tasks, if there are too many tasks, the leaky bucket throttle the tasks, and so you can avoid processing too many requests. Yes, that's the leaky bucket algorithm. Very simple. And I use a library called Limiter. It's a Node.js library for rate limiting. It doesn't require any additional servers like Redis. It's a in-memory rate limiter, and it doesn't use an IP or anything. So I use it to simply rate limiting the requests to the authentication endpoint. And meanwhile, the attack has stopped, so I started running the server again. So everything is fine now. Okay. So the discussion is that how to prevent other similar attacks. I've implemented the leaky bucket algorithm so it can avoid such a brute force attack. So there are still possibilities to attack my server, and so there are some options to protect further. such as rate limit every API endpoint, not only the authentication endpoint, but also other endpoint, and user WF, which is a web application firewall like Cloudflare. So Cloudflare provides DDoS mitigation, and they provide firewall for some layers, like website DDoS protection for application layer. So it looks very simple and maybe cheap, starting at $0. The next one is to require nonce. This technique is used by Let's Encrypt. Piratz told me. This is RFC. So before sending a post request to the server, an Acme client needs to have a fresh anti-replay nonce to put in a nonce header of the JWS. In most cases, the client will have gotten nonce from a previous request. So the server requires a nonce, and it can prevent some attacks from the botnet. So this technique makes the API a little bit hard to exploit by requiring a nonce. Yeah, this works for some attacks using a botnet. Yeah, pretty good, great. So Piras told me this technique on the Twitter. And last one is to implement signed request. This is the most complicated one, but it looks promising. So GVKT told me this technique. So this example is Tinder's, and yeah, obviously it's very complicated. So I think it's possible to implement by using a hash-based message authentication code. Yeah, it looks promising. So by the way, Inkdrop is a small business, and it doesn't have a free plan. This means that I don't have a large user base, unlike other popular services. So I don't know why they attacked my server. It's a very small service. So I think it should be not so cost effective for attackers to spend so much time and effort to target such a small service. So making it hard to exploit would work, like rate limiting plus some application level protection. It make them not worth attacking, I think. And the best way is, of course, hiring a security guy. And yeah, I would love to do that in the future, but it's not. It's expensive, so I'm not planning to do that. Anyway, thank you so much for helping me solving this incident, and I'll keep learning and improving the security. Yeah. This was interesting one. This was an interesting one, and I learned a lot. Yeah. So thank you for watching, and have a productive day.